Okay, so today we're going to cover one distribution that is called the T distribution. The T distribution. The T distribution is very similar to the standard normal distribution. It's a bell-shaped distribution, has the mean equal to 0. Okay, so it means that these numbers are positive and the left numbers are negative. Okay, it's symmetrical, but the difference is the T distribution is a more conservative, if you will, distribution. So it's shorter and fatter. Shorter and fatter. So if, let me rewrite this. If the T distribution, if the Z distribution, I'm going to use the pink. If the Z distribution is this one, okay, this is the Z distribution, the T distribution would look like shorter and fatter. So it looks like something like this. Okay, so it's shorter and fatter. Now, as you know how to read the standard normal distribution tables, you have to know how to read the T distribution tables. Now, the T tables are in your book on page 860. Okay, what you are going to see over here is one extra parameter that the T distribution has, that is the degrees of freedom. How many degrees of freedom are we going to use? N minus 1. What is N? N is the sample size. Okay? So, in the left side of the distribution, you're going to find the degrees of freedom. Okay? From 1 to, go to the other page, to 100, and then infinite. Okay? So you have the degrees of freedom from 1 to 100. And you are going to use the degrees of freedom for this table using N minus 1, where N is your sample size. So if the sample size is 20, you're going to use 19 degrees of freedom. Now, on the top of the distribution, you're going to find 3 rows. The first row is what is called one tail. And one tail is nothing but alpha. Is one tail. 2 tails is nothing but alpha divided by 2. And confidence level is the confidence level, of course. Remember that the previous class, I gave you a table saying what is the confidence level, what is alpha divided by 2, and what is C of alpha divided by 2. Remember that? Well, in these tables, you have exactly the same, but one tail means alpha, 2 tails means alpha divided by 2, and the confidence level is, of course, okay? Now, inside the table, you are not going to find probabilities like in the standard normal distribution. Inside the tables, you are going to find the value of the T value, not the probabilities. It's the T value. Because the probabilities are where? On the three top columns. Okay? Right? Are you following me? So, for example, if I have a T distribution with 20 degrees of freedom, and I want to know what is the 90% confidence interval, what would be the T's? what would be this t and this t? Remember that this is a symmetrical distribution, so this value is positive and this value is negative. Okay? So, 20 degrees of freedom. Look at the 20 degrees of freedom is right here. And I want to know the 90% confidence interval. Go to over here and the third column, 90% confidence level or confidence interval. And then go down and you're going to see that 1.725 and negative 1.725 are the values that establish this. That's it. I mean, it's pretty easy. So you know that alpha in this case is equal to what? 0.1. Alpha divided by 2 is equal to 0.05. So this one over here is 0.05, and this one over here is 0.05. So both are 0.1, and you can see it in the table. The two tails is 0.1, and one tail is 0.05. That's it. I mean, if you understand this and you know, yes, right? Okay. So and that's it. I mean, if you know how to read the t-table, that's pretty easy then, because yes.
In the book, it says 2 tails is 0.1 and 1 tail is 0.05.
Yes. Yeah, exactly.
And you put 1 tail is 0.1.
No. Alpha is 0.1. The two tails.
Okay.
The two tails is alpha. The one tail is alpha divided by 2. Okay? Now, remember, confidence interval. When sigma is known, remember the formula is x bar plus or minus. Again, plus is the upper limit and minus is the lower limit of the interval of z alpha divided by 2 sigma over square root of n, right? That's the other class. That's the past class. When we know the standard deviation of the population, we're going to use this formula. What happened when we don't have the standard deviation of the population? We have to estimate it. And the only way that we can have to estimate the standard deviation of the population is using the standard deviation of the sample. Okay? So when sigma is unknown, when we don't have sigma, we have to use S, the standard deviation of the sample. And if you are going to realize that the two formulas are so similar, because we're going to use x bar plus or minus t, this t distribution of alpha divided by 2x over the square root of n. So instead of z, we're using t, and instead of sigma, we use s. And why we have to use t? Because remember, it's a more conservative or fatter distribution, and it's going to give us a wider interval. And we have to have a wider interval because we are estimating the real standard deviation of the population using the standard deviation of the sample. That's it. That's it. So when you know sigma, use this formula. When you do not know the sigma, you use this formula. And that is the confidence interval for the population mean. Okay? So I am confident, depending on the confidence level we use, that the real population mean is in this interval for this situation, and in this interval for this other situation. Okay. Right? That's it. Let's do problem 817. That's it, guys. It's all over, man. Really. 817 says. Where's my book? Okay. 817. Says. What is that? Construct a 90% confidence interval to estimate the population mean using the following data. X bar is equal to 25, S is equal to 5.2, and N is equal to 21. Papa? And then use the formula, that's it. How many degrees of freedom? We're going to use T. Let me put it in here. Alpha divided by 2 comma n minus 1. Those are the degrees of freedom. How many degrees of freedom? So we're going to use, since we don't have the standard deviation of the population, we're going to use that formula over here. X bar plus or minus T of alpha divided by 2 n minus 1 S divided by square root of n. What is X bar? 25. Plus and minus, and again, plus is the upper limit and minus is the lower limit of the interval. T of alpha divided by 2, n minus 1. Remember, we are dealing with the 90% confidence interval. So go to the T table. And I think we already have that one. It's the same one as the example we did before. It's 20 degrees of freedom because we have 21, the sample size. So we use n minus 1, 20 degrees of freedom. So we go to the row where it says 20 and go to the confidence interval 90 and you find 1.725. So it's 1.725 times 5.2 divided by the square root of 21. That's it. So we have that's 25 plus or minus 1.96. Okay, remember 1.96 is the margin of error. So it's 25 minus 1.96. So it's the confidence interval is 23.04 through 26.96. So what I'm saying is that I am 90% sure. So that's my confidence level. I'm 90% sure that the real population mean is between 23.04 and 26.96.
What's that?
What?
What's that? 25 plus 1.75?
Plus or minus.
Plus or minus 1.75.
Times 5.2 times S.
Oh,
5.2 divided by the square root of n or the square root of 21. Right? So what I'm saying is that I am 90% sure that the real population mean in this case is between 23.04 and 26.96. That's it. Now let's cover the confidence interval. Any questions? Let's cover now the confidence interval for the proportions. So we have seen the confidence interval for the mu when sigma is known, the confidence interval for the mu when sigma is unknown. Now we're going to cover the confidence interval for the proportions. And that is nothing but P. What is P? The proportion of the sample. Plus or minus Z of alpha divided by 2 times the square root of P times 1 minus P divided by N. 1. That's it. That is the formula that we're going to use. So we have 3 situations, and this is the third one. This is the formula that we are going to use for confidence interval for proportion. We have the P. What is P? P is the proportion or the sample proportion. Right? And that's it. Say Z of alpha divided by 2 is the standard normal distribution, and you already have that table. And your book has a table. I mean, we forgot to include another value over here. I think, yeah. On table 8.2 on your book, 383.45, I strongly recommend that you put that table in your cheat sheet because it has the 80, 90, 95, 98, and 99 confidence interval. 345. That is the table. Remember that I gave you a table the other day? Well, it's very similar to this one, but I didn't include the 98. Okay, the 98 is also included in this one. And these are the same Z of alpha divided by 2 that you're going to use for, so this table, the table 8.2 are going to be used in both the confidence interval for the mean when sigma is known, and the confidence interval for the proportion when proportion. That's it. Okay? With this confidence interval, we want to know what is the real population proportion. And this is the confidence level we use. Okay? The Z of alpha divided by 2 give us the confidence level that we are using. Okay? And we're saying that the real population proportion is in this range. That's it, guys. As simple as that. So let's do a problem in order for you to understand these concepts. I have 8.29, which is not part of the homework. 8.29 says construct a 90% confidence interval. So they want a 90% confidence interval to estimate the population proportion with a sample proportion equal to 0.36. So P is equal to 0.36. And a sample size equal to 125. With this data, we want to know, with a 90% confidence level, what is the real population proportion for these things. So, I mean, we're going to use P plus or minus C of alpha divided by 2 times P times 1 minus P divided by 8. That's it. Just plug the numbers in the formula. So it's 0.36 plus or minus, what is Z of alpha divided by 2? Go to the 8.2 table. And for a 90 confidence level, we're going to use 1.645. That's it. I mean, you don't need to read the table. The Z table is 1.645 for a 90%. Times the square root of 0.36 times 0.64 divided by 125. That's it. 0.36 times 0.64 divided by 125. Square root times 1.645. Is 0.36 plus or minus 0.07. Okay? So, I am saying that 0.29 through 0.43 is my confidence interval. So I'm saying that I am 90% sure that the real population proportion is between 0.29 and 0.43.
You get 1.645.
1.645 came from the table. From the table, it has to be 345, 90%. Go, the T value is 1.645. If we were using the 95% confidence level, we would use 1.96 and so on. Okay, 0.345. Okay, so they tell us 90%, and for 90% we use 1.645. Got right?
I see it.
And this is just math. You plug these numbers in your calculator, and you ended up with 0.07. So it means that it's 0.36 plus or minus 0.07. So it means from 0.29 through 0.43. And I am 90% sure that the real population proportion is between 0.29 and 0.43. That's it. Easy. Easy, guys. Easier cannot be.